Thanks for tuning in. Please like, subscribe, and check out my Instagram for cool science and not science stuff. Welcome back to Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to discuss one really important topic in life, and that's why do cats purr? And not only do we want to understand why they purr, but it's also important to understand how they purr because that can actually lead into some of the whys. So let's take a look and see what the science says. Now, to be completely honest, science is not exactly sure whether or not cats voluntarily purr or involuntarily purr, meaning whether or not they have conscious control of this. Or it could end up being a combination of both, depending on the situation. As of right now, the best hypothesis we have as to how cats purr is that it begins in the cat's brain with something called a neural oscillator. What's an oscillator? Well, an oscillator is something that bounces between two values, so off, on, or up, down. In the case of the cat's brain, it's sending rhythmic, repetitive electrical signals called action potentials to the muscles of the larynx. The larynx basically connects the cat's mouth and nose to its respiratory system. And it also contains vocal cords, which not in cats but in humans allow us to talk, and then also associated muscles. And the way that the neural oscillator works is it sends alternating signals to these muscles in the larynx that cause them to contract and relax, contract and relax. And this actually causes the glottis, which is basically an opening at the top of the larynx, to dilate and constrict, which in layman's terms means it opens and closes, and it opens and it closes. Let's take a look and see what that looks like. This right here is a view from above of the larynx, and this hole right here in white represents the passageway that leads basically from the mouth and the nose down into the respiratory system. And so this hole would basically be the glottis. Now this hole can decrease in size and it can increase in size. If this hole increases in size, that would be to dilate. If it decreases in size, that would be to constrict. And so these yellow structures right here are neurons that are coming from the neural oscillator in the brain. So what we'll see in a moment is first the neural oscillator through these neurons up here will cause certain muscles in the larynx to contract, which causes this hole to constrict. Then certain neurons from the neural oscillator cause those muscles to relax. And then that allows this hole to increase in size, to dilate. And we'll see an alternation between constriction and dilation. So this alternating constriction and dilation of the glottis occurs so quickly that it's actually a vibration, and it occurs at a frequency of 25 to 150 hertz. Again, 25 to 150 cycles per second. That's extraordinarily fast. And that actually produces what we hear and feel as purring in our cats. Now that purring triggers certain neurons in the cat's brain to release this hormone called beta endorphin. Here's the incredibly large chemical structure of beta endorphin, and you've probably heard of endorphins before. For example, whenever a runner goes on a really long run, they get a runner's high. And it's basically where pain goes away and they're really enjoying themselves because of that release of beta endorphin and related compounds. And in general, beta endorphin causes increased pleasure and well-being in any organism where we have that beta endorphin. And so we usually think of cats purring when they're happy and relaxed, when they're sitting in our laps, right? And so that would make sense if beta endorphin's released at those times because it increases pleasure and well-being. Cats actually purr in a variety of other circumstances, including pain, stress, and even, unfortunately, before their death. And it has to do with the fact that beta endorphin is responsible, in part, for reducing the perception of pain. Beta endorphin acts on opioid receptors within the cat's body, including our own bodies too, to reduce the perception of pain. This is actually why runners are able to get a runner's high. Because of the release of these endorphins, the runner's not able to perceive the pain that they would normally be in without that beta endorphin. But also, when a cat breaks a bone, they actually purr to initiate bone healing. Now, it is true, there are mechanisms in the body to cause bone healing independent of purring. In fact, this vibration at a frequency between 25 and 150 hertz is just within the proper range to actually accelerate bone healing following a fracture. And this is one reason why cats, when faced with a broken bone, tend to heal faster than most other pets, including dogs, as obviously dogs do not purr. And while purring by itself might seem a little bit trivial to study in any real detail, it actually has some potentially massive implications for space travel. For example, when astronauts go into space for any extended period of time, they tend to lose bone mineral density in proportion to how long they're in space. That's because there's no gravity. So, in order to maintain bone density while in space, the astronauts could potentially have their bones subjected to vibration like this. This could potentially mitigate the effects of anti-gravity on loss of bone mineral density. Female cats also purr when they're giving birth, and this is likely because birth is painful, and so the release of beta endorphin when the cat purrs actually acts to reduce the perception of pain that would normally be experienced. Additionally, when kittens are nursing with their mother, they may actually purr to indicate that they're getting adequate milk. If the kittens do not purr, it means that they're not getting that nutrition. And cats also may purr when they're stressed. Remember, purring releases beta endorphin, which increases feelings of well-being, which may serve as a sort of therapy to counteract that stress. Now, we mentioned that purring triggers the release of beta endorphin in the cat's brain. It also may work in the other direction. Beta endorphin can cause more purring, and this basically occurs in sort of a positive feedback cycle until some stimulus ends that feedback. And one more amazing fact here. Remember we said that this neural oscillator causes alternating dilation and constriction of the glottis. Well, based on the animation that we saw, remember that dilation and constriction, particularly the constriction, doesn't close the glottis all the way. It just closes it a little bit, opens it a little bit, and so on and so forth. So a cat can actually continue purring during the entirety of its normal breathing cycle, during both inhalation and exhalation. So hopefully this video was interesting to you and gave you some good information on how and why cats purr. Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you.